In this video, we're going to review the main methods of factoring. Whenever they say to factor, they mean to rewrite the original expression as a multiplication problem. So rewrite in a multiplication format. I'll just write rewrite as multiplication, but you're rewriting in a multiplication format. And they're going to expect you to know how to factor here and there throughout this course. So starting with the first slide here, looking at A, let's go ahead and factor the following. It says factor x squared minus 4. We have two terms. Terms are separated by plus and minus, is how I know we have two terms. And as I look at those two terms, they're both perfect squares. If I did the square root of the first term, which is x squared, I get back out a non-decimal answer. The square root of x squared is just x because the square root and the square cancel each other out. If I look at after the minus symbol, the 4 is also a perfect square because the square root of 4 is a nice whole number answer of 2. What times itself is 4 is 2. So when I do the square root to both terms, I notice that they are both perfect squares. X squared is a perfect square and 4 is a perfect square of 2. X squared is obviously a perfect square of x. So whenever you have minus symbol of two terms, you have a minus symbol in the middle, and both the terms are perfect squares, this is going to be called the difference of perfect squares. The difference, I'll just put diff for difference, of perfect squares. And the pattern is going to be the following. So go ahead and write two blank sets of parentheses. Remember, we're factoring, so we're going to rewrite this as in a multiplication format. And to get a negative, it must be that they took a positive times a negative. So whenever you're factoring the difference of perfect squares, you'll have one plus and one minus every time. And then the square root of the first term goes in the first spots of the parentheses. We just said the square root of x squared is x, so that goes in the first spots. The square root of the last term goes in the last spots. So the square root of 4 was 2, so 2 goes in the last spots. So when I rewrite x squared minus 4 in a factored format, I get x plus 2 times x minus 2 is the final answer. The order you multiply in does not matter. So if you wanted to do x minus 2 first and then x plus 2 last, that's fine as well. They're both sharing the same exact answer. Looking at B, B is very similar. We have two terms again. We have x squared and 4, which we just said are perfect squares. However, there's a key difference here. Instead of minus, we have plus. There is no sum of perfect squares rule. So when that happens, the only thing you can check for is if there is a GCF, which stands for greatest common factor. In other words, is there a number or a letter that divides into both terms other than the number 1, because 1 divides into anything. So is there a letter that x squared and 4 have in common? No, because 4 has no letter attached to it, and there is no number in front of x squared other than 1. So there is no number they have in common or letter they have in common, and the biggest number that divides in there is 1. So when there's just a plus symbol in the middle of perfect squares and their GCF is 1, what I'm getting at here is that it cannot be factored. There's no way to rewrite that as anything other than 1 times x squared plus 4 back again. But for our purposes, we would just say this is not factorable. Looking at question C now, factoring again, 4x squared minus 9. We're back to a minus symbol in the middle, and both of the terms are perfect squares again. The square root of 4x squared, well, the square root of the 4 in front is 2. The square root of x squared is x. So what times itself is 4x squared is 2x. And if you do the square root of the 9 after the minus symbol, that equals 3. So we do have perfect squares because when you do the square root of each term, it's not a decimal. It's a nice whole number answer. And we have a minus in the middle, so C is very similar to question A in that we're back to the difference of perfect squares. So you would jot down your two sets of parentheses. When you have a minus, only a positive times a negative could give you that. The square root of the first term goes in the first spots. That was 2x. Whoa, that's a sad looking 2x. Let me try to draw this at least a little bit nicer. My messy handwriting here. There we go. 2x goes in the first spots. The square root of the last term goes in the last spots. The square root of the last term was 3. So 3 goes in the last spots. So the final answer is 2x plus 3 times 2x minus 3. I have one more harder question, and I do want to emphasize a point here, which is the first step to factoring anything they throw at you technically is you should be checking for a GCF first, a greatest common factor first. So as I look at D, it wants us to factor 32x to the fourth minus 50. When you first look at it, you might be going, okay, well, 32 and 50 are not perfect squares. So you cannot use the difference of perfect squares method yet. However, there is a number besides 1 that divides into both terms. So thinking about what's the largest number that divides into both terms, 2. 2 divides into 32 and 2 divides into 50. And there is no number larger than 2 that would divide into both. They do not have a letter in common because the 50 does not have an x beside it. So 2 is the GCF. So the way you factor using the GCF is you put the GCF in front of parentheses, and then whatever the GCF is, you divide your terms, both of them, all the terms, by the GCF to figure out what to put in the parentheses. So I put the GCF of 2 in front. Now let's do 32x to the fourth divided by 2. So when I do 32 divided by 2, I get 16. Bring down the x to the fourth, bring down the minus symbol in the middle. 50 divided by 2 is 25. There we go. So GCF, put the GCF in front of the parentheses, divide all the terms by the GCF, and that's what you put in the parentheses. You're going to know if you did it correctly because if you were to distribute the 2 back in, you would get back the original expression. So you could distribute it to check it. We're not done yet because we can go further. So now that I've divided out the 2, if I look at what's inside the parentheses, 16x to the fourth and 25 are both perfect squares. And there's a minus in the middle. So this is a perfect difference of perfect squares in the parentheses. The square root of 16x to the fourth, well, the square root of 16 is 4. The square root of x to the fourth, what times itself is x to the fourth, is x squared. So 4x squared times 4x squared gives you back the 16x to the fourth, in other words. 16x to the fourth is a perfect square of 4x squared. If I do the square root of 25, that is, of course, 5. So these are the difference of perfect squares. So let's go ahead and put it all together. So bring down the 2, it's still in front. And we're focusing on factoring the 16x to the fourth minus the 25. It's difference of perfect squares yet again, so we have a plus and a minus. The square root of the first term was 4x squared. It goes in the first spots of the parentheses. The square root of the 25 was 5. The square root of the last term goes in the last spots. You got to constantly check with factoring. Can you go further? There is no sum of perfect squares rule, we said, so the only terms to check is the 4x squared minus 5, but because 5 is not a perfect square, if I do the square root of 5, it's a weird decimal, that means, yay, we cannot go any further. So here is the completely factored version at the end. So final answer would be 2 times the quantity 4x squared plus 5 times the quantity 4x squared minus 5. there was an algorithm to factor the difference of perfect squares. There's also going to be a formula for the difference of cubes, the difference of perfect cubes. Not only that, but there's also a formula for the sum of cubes, which is pretty impressive because there was no formula for the sum adding perfect squares. This is more of a formula, though, than an algorithm. So let me go ahead and jot these formulas down. So starting with the difference of cubes, so let's say you have some term A that's cubed minus some term B that's cubed. And for sum of cubes, let's say that you have A cubed plus B cubed. So I'm going to rewrite both using their formulas. So what's going to happen when you factor either one is you're going to get a binomial times a trinomial. So binomial means 2 terms times trinomial means 3 terms. For both of these answers, after the equals bar, you're going to have A first, then you're going to have B next, and then beginning the second set of parentheses, you'll have A squared. Then in the middle, you'll have A times B for both, and you'll have B squared last. And then a kind of a cheesy algorithm here to remember the signs for the answers is think of soap. So the first sign is going to be the same as the original sign in the middle. So in the difference of cubes, the original sign is a minus. So the first sign is going to be the same. It's going to be a minus as well. Whereas in the sum of cubes, you're dealing with a plus. The sign is the same as that, which is a plus again. The next sign is going to be the opposite of the sign you just wrote. So for a difference of cubes, if the first sign was a minus, the next sign will be plus. For sum of cubes, since the first sign was plus, the second sign will be minus, the opposite of that. And then the last sign is always a plus or always a positive. You can think of that AP either way. So you're always going to do plus B squared in the formula, plus B squared. So let's look at this formula in action. They want us to factor the following. So A, we got x cubed minus 8. I have 2 terms, minus in the middle, and they're both perfect cubes this time. So if I look closely, I can do the cubed root of both the terms and get a whole number, not a decimal out, is why I say they're perfect cubes. So if I do the cubed root of x cubed, in other words, what times itself is x cubed would be x. And if I do the cubed root of 8, the number after the minus sign, so what times itself is 8 would be 2. Now if you get a not so nice number in the homework and you're asking yourself, okay, what is the cube root of this number? Let me go ahead and pull up the graphing calculator onto the screen so I can show you how you would do cube root of a number in the graphing calculator. For cube root, you are going to first hit the math button, which is right here. It's the 3rd button down on the left side of the graphing calculator. So as I hit the math button, I look through the options that come onto the main screen. I'm going to use option 4 for cube root. You can either scroll down to option 4 using the down arrow key and then hit enter, or you can just simply hit the number 4 to select that option. The cube root comes onto the main screen. I type in the 8 underneath, then I hit enter for equals, and there we go, the answer is 2. So I'm going to rewrite x cubed minus 8 as x cubed, x in parentheses, minus, and then 8, as we just saw, is really 2 cubed. You don't have to do this step. I'm just doing this because I really want to emphasize what A is and B is. So if you look above at the difference of cubes formula, we plug in A and B into the right side of the formula. So I don't want to plug in a cubed, which is the first term. I want what is cubed. That is a. So a is equal to x, and b is equal to 2. And now I'm ready to plug in to the difference of cubes formula, which I'm circling in red pen on the top of the screen, the right side. So I'll draw a little divider here. We're going to have a binomial times a trinomial. So for the binomial, they say a minus b. A is really x, so x minus b is 2. Parentheses again, now a squared. If a was x, that gives me x squared plus a times b, so x times 2 or 2x, plus b squared. B was 2. 2 squared is 4. So plugging into the formula for difference of cubes, I get the quantity x minus 2 times the quantity x squared plus 2x plus 4 as the final answer. Let's try another one. Looking at part B, question B, again we're going to factor x cubed plus 27. So yet again I have two terms and they're both perfect cubes. I have x literally to the third power. 27 is a perfect cube as well. So a is always going to be the cubed root of the first term, which is x cubed. The cubed root of x cubed, the 3's cancel each other out and you're left with x, so a equals x again. B equals the cubed root of the last term, which was 27. So it's up to you if you want to do that in your head or use the math button, option 4. But what times itself 3 times is 27 would be 3. So B equals 3. So if you wanted to, you could think of this as x cubed plus 3 cubed. Now it's a plus symbol in the middle, so this is the sum of cubes rule that I'm circling in blue pen. This is the right side of the equation we're going to plug into. We've identified a is x and b is 3. So here we go, parentheses, a plus b. So that's going to be x plus 3 times a squared. A was x, so that becomes x squared, minus symbol, a times b, which would be x times 3, or 3x, plus symbol, take b and square it. B was 3. 3 squared is 9. So when we use the formula for sum of cubes, we get x plus 3 times the quantity x squared minus 3x plus 9. Now it's time to factor the trinomials for 3 terms. So we're going to factor each one of these problems. Starting with question part A, we're going to factor x squared minus 7x minus 8. Couple different ways you can factor trinomials. So please, if you don't like the way that I'm doing it in this video, feel free to use whatever way you're familiar with or that you've learned in your past. That's fine too, just so you get the right answer. For me, if it's a 1x squared in front of that trinomial, so 1x squared is the leading term, then it's going to be a quicker question than if there was some other number besides 1 in front of the x squared. So we know factor means rewrite as multiplication, so I'm going to get 2 blank parentheses for multiplication ready to go. And I take care of the signs first. You always bring down the first sign that's showing there, which is a minus. And then to get the other sign, you multiply the 2 signs together. Negative times negative is positive. So again, when you're figuring out what signs to use, you always bring down the first sign, which in this case was a minus sign. And then you multiply the 2 signs together to get the second sign. Negative times negative is positive. Now, why it's a much nicer question if you have a 1x squared is because the only thing that gives you 1x squared is x times x. And the multiples that give you the first term go in the first spots of the parentheses. So really, the only question is what multiples of 8, the last term, should go in the last spots. So as I think about all the multiples of 8, it could either be 2 times 4, I'll use a dot for times up here, or it could be 1 times 8. To figure out which is the best answer, keep in mind with the trinomials, the goal is to get back the middle number. So I want to get back a negative 7x, or negative 7. I need to abide by the sign rules here. So if I'm going to minus and I'm going to plus, the only multiples of 8 that would give back 7 would be if I minus the 8 and add the 1. And then to check to make sure if it's correct, you could FOIL your answer back out to verify that you really do have x squared minus 7x minus 8 back again. But for the final answer, you should be getting x minus 8 times x plus 1. Remember, the order does not matter, so if you had the x plus 1 first and then the x minus 8 last, that works too. Taking a look at question B, same directions, we're going to factor 3x squared plus 15x plus 18. Technically, before we do any type of factoring, we should always check for a GCF other than 1 first, a greatest common factor. And here there is a number besides 1 that goes into all the terms. Now, they do not all have an x in common because 18 does not have an x on it, but they are all numbers divisible by 3. We have 3, 15, and 18 here. So the GCF, the biggest number to go into all the terms, divide into them, is 3. So step 1, I'm going to use the GCF method of factoring first. You list the GCF, 3, in front of parentheses, and then to figure out what to write in the parentheses, you divide all the terms by that GCF. So I'm going to divide all the terms by 3. So when I do 3x squared divided by 3, it cancels to 1x squared. Plus, when I do 15x divided by 3, I get 5x. Bring down the next plus symbol. When I do 18 divided by 3, I get 6. So let's go ahead and just move this down so you can see what I did a little bit better here. But again, the GCF was 3. So I divided that GCF out of all the terms and put it in front of parentheses. Divided it out in front. Okay, then we're not done until we've factored everything that can be factored. We can still factor the trinomial inside the parentheses further. So I'm just going to bring the 3 down, that's in front, and not worry about it ever again. It's part of the final answer, but I'm done with the 3. So now, maybe I should color code this a little bit better. But now, I'm going to worry about factoring x squared plus 5x plus 6. I'll bring down the first sign just like I did in part A. The first sign is a plus, drop it down. And then we're going to multiply the two signs together to get the other sign. So positive times positive is another positive. Since this is a 1x squared, it has to be x times x. That would give 1x squared back again. 6, the multiples of 6 could be either 6 times 1 or 2 times 3. Keep in mind the goal is the middle term, which is a positive 5. If we need to plus and plus, it must be that we're going to plus 2 and plus 3 to get back that positive 5 in the middle. That's the only combination using those signs of double plus that would work. So here's my final answer. 3 times the quantity x plus 2 times the quantity x plus 3. Whoop, I know that was a sad little parenthesis I drew there. There we go. Let's look at a few of the harder trinomials. We are going to factor the following yet again, looking at question A. 6x squared plus 5x plus 1. As I look at that question, the GCF is unfortunately 1. There's no number other than 1 that divides into all the terms, nor do they all have a letter in common because the plus 1 at the end does not have an x tagged into it. So that means our leading coefficient, the number in front of the biggest powered x there, is a 6. Whenever you don't have a 1x squared and it's a trinomial, so in other words, if it's any other number in front of the x squared with these trinomials, that means more work to be done. Yuck. We're going to need a method to factor this. I use guess and test. You don't have to. If you want to use a C method, that's fine. If you want to draw the tic-tac-toe board, I've seen students do that. That's fine. Colombian method I've seen, that's fine too. However you want to do it. But I'm going to use guess and test. So I'm going to throw down my parentheses and I'm going to use the signs first. So bring down the first sign, it's a plus. Multiply the two signs together to get the other sign. Positive times positive is another positive. Now, thinking about what multiples there are of the first term, 6x squared could be 6x times 1x, or x, and I'll use a dot for times, or it could be 2x times 3x. Keep in mind the goal is always the middle term, which is a positive 5x. The multiples of the last term, since the last term is 1, it has to be 1 times 1. That's the only pair that works. So the multiples that correspond to the last term go in the last spots. So for this question, we're really asking ourselves, okay, which combination should we use to go in the first spots? Should we use 6x times 1x, or should we use 2x times 3x? I like to start with the smaller pair of numbers overall and go from there. So I'm going to start with 2x times 3x, and I'm going to throw them in there. And then it's literally guess and test to see if we got back the original expression. Now you could test this by foiling the whole thing out, but that's a lot of work. And really, if you think about it, we don't have to FOIL the whole thing out. We already know the first pair is going to give us back the first term of 6x squared, and we already know the last pair of numbers, 1 times 1, is going to give us back the last term. So what I do with this method is I only check the O and the I, the OI, you could think of it as from the FOIL. And I check to see if the OI gives me back that middle term, which was that positive 5x. So let's check it out. The outer terms, that's what the O stands for first. If I do 2x times positive 1, that's going to be 2x. The I stands for the inner terms. If I do 1 times 3x, that's positive 3x. 2x plus 3x gives me, yay, it gives me back 5x, which is what I wanted. So because I got back the middle term, same sign and all, that must mean that I have a correct answer. If I did not get back the right middle term, if I did not get back 5x, then I would try another pair. I would try the 6x times 1x combination, and I'd check it all over again. Let's see a few more with these harder trinomials. But again, part A, we get back 2x plus 1 times 3x plus 1 after we factor those. Looking at question B, now they want us to factor 3x squared plus 2x minus 8. The GCF is 1, only 1 divides into all three terms. So that means we are stuck with a 3x squared, unfortunately, not a 1x squared. So that means it's going to be guess and test just like part A, unfortunately. I'm going to go ahead and throw down my blank parentheses, and I'll take care of the sign first. Let's bring down the first sign, it's a positive, and then we multiply the two signs together to get the other sign. So positive times negative, 4, negative. So I have one of each sign for this particular question. My goal, the middle term in this one, is positive 2x. When I think about what multiples make the first term, 3x squared, the only pair that works is 3x times 1x, or x. The problem here is I don't know which should go with the plus symbol and which should go with the minus symbol. It is literally just guessing, throwing them in there. So I'm going to go ahead and just put the 3x with the plus symbol and the 1x or x with the minus symbol to begin. 8, the multiples could be either 2 times 4 or 8 times 1. I like to pick the overall smaller number pair to begin. So I'll just try 2 and 4. And again, it's just guess and test. I have no clue what should go where. So I'll just put the 2 here and the 4 here. So I currently have 3x plus 4 times x minus 2 as my first guess. So I'm going to check it with the OI, the OI part of FOIL. See if I get back that positive 2x, that middle term. That's my goal. So the outer terms, I have 3x times a negative 2, which is negative 6x. My inner terms, I have positive 4 times x, which is positive 4x. When I combine the terms, negative 6x plus 4x is negative 2x. Oh, I'm so close. My goal was a positive 2x. I got back negative 2x. So whenever you check your answer and you get back the right number, only the sign is wrong, that must simply mean if we switch the signs of our guess, we will be good to go at getting the right answer. So that's what I'm going to do up here. I'm going to switch the signs. So I'm going to make this plus a minus. So it's now 3x minus 4. And I'm going to make this minus a plus. So I now have 3x minus 4 times x plus 2. And now let's check again. That should do the trick, but let's go ahead and check just to be safe. So this is check attempt number 2. We're going to OI again. We're looking for that positive 2x is our goal. The outer terms, 3x times positive 2 is a positive 6x. The inner terms, minus 4 times x. I have 6x minus 4x, which is positive 2x. Yay, which is my goal. So that must mean that this is the correct answer. I apologize for my messy handwriting, but you should be getting the quantity 3x minus 4 times the quantity x plus 2. Let's try another of these harder ones to factor here. So now I am looking at question C. Same directions, let's factor 3x squared minus 10x minus 8. GCF is 1, so I am stuck with a 3x squared, which means yet again, let's do some guess and test. I'll throw down 2 blank parentheses. First sign's a minus to drop down. Multiply the 2 signs together. Negative times negative is positive. So I have one of each sign yet again. The only multiples that give me 3x squared are 3x times 1x, or x. I have no clue what should go with what. It is literally guess and test. So let's just put the 3x here and the 1x here. The 8 could be 2 times 4 or 8 times 1. I like to, as usual, pick the overall smaller pair to begin. So I'm going to try 2 and 4 again. And let's just throw them in there. So let's put the 2 here and the 4 here. Our goal this time is a negative 10x when we do the OI check. So let's go ahead and check. I currently have 3x minus 4 times x plus 2. I'm thinking that's not going to work because we just got that as the answer to part B a minute ago. This is a totally different expression, but I just want to show you the process of knowing when an answer is wrong or right. So I'll go ahead and check it anyway. So the outer terms, 3x times positive 2 is positive 6x. The inner terms, minus 4x, 6x minus 4x, like we said in part B, is still 2x. So my point here with this guess is our goal was a negative 10x. When we checked it, we got a totally wrong number. We got 2x. This is nowhere near what we wanted. So when this happens, I would recommend to switch the last pair of numbers and try again. So if I switch those last pair of numbers, I'm going to move the 2 to the first spot and the 4 to the last spot. And if this still doesn't work, then I'm going to have to use a different combination. Then I'll have to go to the 8 and 1 pair and try again. But let's check this first. So we're on attempt number 2 now. And it's not letting me erase my last attempt, so I'm just going to scribble through it. But the outer terms are now 3x times positive 4, which is 12x. The inner terms are minus 2 times x for minus 2x. 12x minus 2x is 10x. Oh, I'm so close. So now, with this guess, we have the right number, 10, just the sign is wrong, because we wanted a negative 10x, and we got positive 10x. So just like we mentioned with part B earlier, if you have the right number, just the wrong sign, you just simply need to switch the signs. So this should have been the positive. It should have been 3x plus 2. And over here, it's still not letting me erase, unfortunately, so I'll have to scribble through it. But this is going to be a minus. So it looks like it should be 3x plus 2 times x minus 4. Let's check it. Hopefully this will be the last attempt. This will be the third attempt for these potentially longer questions. So if we do OI now, 3x times negative 4 is negative 12x. The inner terms plus 2x. Negative 12x plus 2x is negative 10x. Yay, that was the middle term we wanted. So this is the final answer. The quantity 3x plus 2 times the quantity x minus 4. If you would like to see some more examples, that's okay. We're going to be factoring some more in the next section.